Yeah. Perfect.
All right,
Yes.
going to share my screen.
Yeah.
I'm just waiting for Zoom to let me share my screen. Here it is.
Yeah. Okay.
Okay, can everyone see my slides?
Yes. We see the slide.
Okay, great. So this talk is about the 5 big ideas in artificial intelligence. I'm Dave Touretzky. I'm a professor of computer science at Carnegie Mellon University, and I'm also the founder and chair of AI4K12.org. And AI4K12.org, part of our mission is to develop guidelines for teaching AI in K-12. So we should probably start with the question of what is artificial intelligence. Artificial intelligence is a branch of computer science. It's concerned with techniques that allow computers to do things that are generally considered to require intelligence. That doesn't mean that the computer does things the same way that people do them. These are not artificial brains, but there are algorithms that computer scientists can develop to do things like understanding language, understanding images. Even if they don't do them exactly the way people do them, it's still useful to have a computer that's able to do these things. And so that's what the field of AI is about. You're already using AI every day in your daily life. When you talk to a home assistant like Alexa, or you talk to your phone, you're using speech recognition. When you watch a YouTube video and there are automatic subtitles, or if you use Google Translate to translate from one language to another, that's AI. If you use your face to unlock your iPhone, or you play with Snapchat filters, that's computer vision, that's AI. Even if you don't have the self-driving car yet, a lot of cars now will give you lane departure warnings. So if the car thinks you're drifting out of your lane, it'll beep at you. The more advanced cars even have emergency braking. So that's computer vision, that's AI. When you make a Google search, if you ask Google, what is an alligator weigh, or what's the second largest city in Honduras, and Google answers you, that's natural language understanding, that's AI. Recommender systems, when Netflix suggests movies you might want to watch, or Amazon suggests products you might want to buy, or Facebook puts news stories into your feed, or Google selects ads for you. These are all AI systems. And then finally, robotics, things like the Roomba that's vacuuming up your house, or the Kiva robots that help automate Amazon warehouses. Those are all powered by AI as well. So we're using AI in our everyday lives, even if we don't recognize that there's AI inside there. AI does pose challenges for society. Many types of work will become more automated. That means that some people may lose their jobs. Many more people will find that their jobs have changed, and they need new skills in order to work alongside intelligent agents that are powered by AI. And there will be new jobs created as well. So things like prompt engineering, or greater need for robotics as more robots come into the workplace. So it's a mixture of changes. Automated decision-making systems. So now people want to use AI to help decide things like who gets a loan, who gets into college, who gets a mortgage. But those systems, we may be worried about them if they're being fair or not. AI can be used for surveillance. For example, face recognition in public places means a loss of privacy. We've seen a lot of deep fakes. So it's no longer the case that you can believe a picture or believe a video, because those things can be faked now with very convincing results. So They're changing our feeling about media. And then finally, large language models, things like ChatGPT, there are some people who are concerned that as these things become super intelligent, they might decide to wipe out humanity. So that could be a problem. So what I want to do in this talk is just give you an overview of the 5 big ideas in AI, what those big ideas are, and then give you some demonstrations of little AI tools that you can play with yourself. So here's the 5 big ideas in AI that we put out at aifork12.org with a little informational graphic here. And the 5 big ideas are, first of all, perception. Second, representation and reasoning. Third is learning. The 4th is natural interaction, which covers a whole bunch of subtopics. And then the 5th one is societal impact, which you can see we put right in the center of our graphic here. So we have a poster that explains the 5 big ideas in a little more detail. We just put out version 2 of this poster. This poster is available in 16 different languages, including Spanish, but we don't have all the translations yet. So if you go to aifork12.org and you look at the Spanish version of the poster, that'll be version 1. And where version 1 and version 2 differs is in some of this discussion of natural interaction, because now we've added a discussion of large language models in Big Idea 4 here. Okay, so let's go through the big ideas in a little more detail. Big Idea 1, perception, it says that computers perceive the world using sensors. So there's a difference between sensing and perception. Sensing is just recording a physical signal, like light or sound, but perception is extracting the meaning from that signal. So here's an example of how a self-driving car sees the world. So the sensing would be forming the camera image, and then the perception would be recognizing objects in that image, like pedestrians you see here, vehicles, traffic lights, and so on. So what happens if you have sensing without perception? Well, here's an example of that. So there is a problem with deer wandering into supermarkets. It happens more frequently than you might think. And the reason that happens is that the automatic doors, they have sensing. They can tell that some object is outside the door, but they don't have perception. So they don't know that it's not a person. So this is what you get when your automatic doors have sensing, but not perception. Let's move on to Big Idea 2, which is representation and reasoning. And for each one of the big ideas, we have a 1-sentence statement of the big idea. So for Big Idea 2, the statement is agents maintain representations of the world and use them for reasoning. And so representation and reasoning are complementary. They're like yin and yang. They go together. Here's an example of Lee Sedol, who is a world champion Go player. And he was playing against AlphaGo, which is an AI program from DeepMind. And AlphaGo was actually able to defeat Lee Sedol, who's one of the best Go players in the world. So the representation in this case would be how the game board is represented in the computer. And the reasoning would be the algorithm that decides what's the next move to make. So representations support reasoning, and algorithms operate on representations. Big Idea 3 is learning. The computers can learn from data. And this is getting a lot of publicity these days. There's a lot of interest in machine learning. There are a lot of job opportunities for people who are machine learning engineers or machine learning researchers. And in part, it's because a lot of the recent successes in AI have been due to advances in machine learning. So AI started in the 1950s. And for a long time, AI programs didn't work very well. And part of that was because we didn't have enough computing power. Computers weren't powerful enough to implement large enough models and complex enough reasoning algorithms. But another part of the problem was that in the beginning, people tried to code AI algorithms by hand, and that turned out to be very difficult. So when machine learning came along, now we're able to use machine learning to create the AI algorithms for us by showing training data to the machine learning algorithm. And that's allowed things like speech recognition and computer vision to be much more successful than they were before. And that really started around 2010. So some people confuse these terms. They think that artificial intelligence and machine learning are the same thing. That's not true. Machine learning is a subdiscipline of artificial intelligence, and it didn't really get started until the 1980s. And then within machine learning, there are many different machine learning techniques. You'll often hear about deep learning or deep neural networks, and that's just one type of machine learning. There are other types of machine learning that don't use neural networks at all. But these deep neural networks, they started to become popular around 2010. And that's when computers got powerful enough that they can run really big neural networks. Before, we were limited to small neural networks, and they couldn't do so much. But when neural networks got big enough, because computers became powerful enough, then they started outperforming the AI systems that people were coding up by hand. And so people switched approaches and started using machine learning to solve many, many AI problems. Big idea 4 is natural interaction. Intelligent agents require many kinds of knowledge to interact naturally with humans. So this is a really broad category. It includes things like understanding language, common sense reasoning. So what do we mean by that? Well, imagine I'm holding up a pen in my hand, and suppose that I open my fingers. So what would happen to the pen if I open my fingers? Well, because of gravity, the pen would fall. But how does the computer know that? So that's an example of common sense reasoning, understanding how objects act in the world. And that kind of stuff has to be programmed into the computer or has to be taught to it if we're using machine learning. Another part of natural interaction is what's called affective computing, that is understanding human emotion. So how can you tell if someone is happy or upset? So there are various cues. You can tell from the language that they use. You could tell from the tone of voice. You could tell from their facial expressions. And so if we want computers to be sensitive to people's emotions, that's another AI problem, right? Recognizing humans' emotional states. And we may want the computer to change the way it responds. So if someone is really energetic, they don't want to be talking to a computer that's got this really dull, slow, plodding voice. That's going to be a downer, right? But if somebody's really upset, then they don't want to be talking to a computer that's talking really fast and is chirpy and peppy, because it's not acknowledging that they're upset. So ideally, the computer should adjust the way it speaks to you based on what it perceives as your current emotional state. And then another area of natural interaction is this notion of consciousness and philosophy of mind. So could computers be conscious? Are they conscious today? No. Could they be conscious? Well, that's an interesting argument. And there are people on both sides of that, whether a computer could ever be conscious or not. The fifth big idea is societal impact. And this one is so complex that we actually have multiple slides on that. We say artificial intelligence can impact society in both positive and negative ways. So it's important when people build AI systems that they be sensitive to that. We tend to focus on the good things that we hope our AI system will do, but it could also end up having bad effects that we want to guard against and protect people from. So, for example, it's more and more common to have AI systems making decisions about people, who gets a loan, who gets into college, even things like who should get parole from prison and who should stay in prison. So who's a safe risk to let out of prison, and who should stay. So when you have automated systems making decisions about people, there are worries that they may be biased, that they may not always be fair. And so that raises the issue of transparency, that we need these systems to explain their reasoning so that we understand why they made the decision that they made. And we need people to be accountable. So it's not acceptable for someone to say, well, that's what the computer decided, so that's what we're going to do. And don't blame me if you don't like the results. People need to take accountability for the systems that they build, and their systems need to be transparent so we understand how those decisions are made. It's not always the case today. So there are some systems that are proprietary that people won't tell you how they made their decision, and that could be a problem. So this is one aspect of societal impact, is when you let computers make decisions about people, are we doing that in an ethical way? Another aspect of societal impact is the economics of AI. So bringing robots into the workplace could increase productivity, but it could also cost some people their jobs. We could have new types of services brought about by AI, but some types of jobs might be reduced. And there could also be whole new careers. So people might get a job as a robot trainer, and their job is to train a robot to do whatever tasks need to be done that day. So there could be whole new lines of work created as a result of AI. The third aspect of societal impact is AI and culture. So as you start living with intelligent assistants and robot companions, what does that do to our culture? How does that make us feel about our society, about our fellow humans, about these robots? Would you let your child travel in a self-driving car alone without a human? I really like this picture here because you can see the girl's on her phone. The little kid in the back is staring at the ceiling. The only person watching the road is the dog, and the dog can't drive. So this is our future, right? This is our future. And I personally have thought a bit about this, and I think people are going to design cars that are safe for children to ride in. So for example, if the kids in the back are fighting, the car will call the parents on their cell phone and say, hey, you want to yell at your kids? They're fighting in the back of the car here. So there's all kinds of room for innovation here. And I think this is going to be really interesting. Okay, so what I want to do now is show you a little experiment. This is a demo called Teachable Machine that was created by Google. And I'll show you the experiment, and then later on, you can always come back later and run this experiment yourself and play with this yourself. So to do this, I'm going to stop the slide display here and switch to my other tab. Can you still see my screen? Yes, you can see the screen?
Yes.
Yes, we can see.
Yes.
Okay, good. So I'm going to run Teachable Machine here. And I think I have to turn my camera off in order for this to work. So I'm going to turn off my webcam. So here's Teachable Machine. You just click on Get Started. And then when it comes up, you click on Image Project and Standard Image Model. Okay, so what we're going to do with Teachable Machine, we're going to teach the computer to recognize when I'm making a thumbs up sign and when I'm not. So we're going to call the first class thumbs up, and we'll call the second class neutral. And there's a couple ways to train Teachable Machine. The simplest way is to just use your webcam. So I'm going to use my webcam here, and I'm going to when I hold down this hold to record button, it's going to record a bunch of images that are going to be used to train a neural network. So I have to show it what I mean by thumbs up, and I have to do it in all these different positions so that it'll understand what thumbs up means. So that's what I'm going to do. I'm going to hold this down and just move my thumb around and collect a bunch of images. So that's thumbs up. Now we're going to come down here to neutral, and I'm going to do the same thing. I'm going to hold, so this is neutral with no thumb. Okay, so now I've collected 78 thumbs up examples. I have 74 neutral examples. I click on train the model over here, and all of this training is being done in the web browser. So it's not sending any of these images to Google. And that's really important for privacy reasons, especially in schools where they're really concerned about student privacy. So what's nice is that all of this is happening inside the browser. It's a little slow because Zoom takes a lot of computing power. And so the teachable machine is competing with Zoom to do this training, but it's almost done. Okay, so it's training up the neural network. Okay, so now it's trained it up and it's looking at the camera. So here's the camera in real time. And this is the output. It's trying to classify this image. Is this a thumbs up image or a neutral image? And it's really confident that this is neutral. So let's show it a thumbs up. Yeah, and it's got that. It realizes this is a thumbs up and this is a neutral. Now, what if I do thumbs down? What does it think about thumbs down? So we didn't teach it to distinguish thumbs up from thumbs down. So it can be a little uncertain in some cases, but pretty much if there's a hand in the image, it's going to say thumbs up. Even if I do a peace sign or something, if there's a hand in the image, it's going to say thumbs up. So it's not going to do well on things it wasn't trained on, but the cases where it's trained on, it can tell neutral no matter where my face is from thumbs up, at least thumbs up with my left hand, because we trained it with the left hand. If I put the right hand in there, it still does pretty good. Okay, so you can have as many classes as you want. We could teach it a peace sign, an okay sign, and you can go back. If it doesn't do a good job, you can go back and edit the training set. So there's a lot of really cool things you can do with Teachable Machine. And this is free, available from Google. So I said this was a neural network. So let's just talk briefly about what that means. Okay, so what's a neural network? It's a large, complex mathematical function that maps inputs to outputs. And neural networks are composed of many simple little units that are sometimes called neurons. So each of these little neurons here, it takes a bunch of numbers as input. It computes a very simple mathematical function, and then it produces a single number as output. But it can send that number to many other units in the next layer. And these connections from one unit to another, these connections have weights attached to them, which are also numbers. So the output of the neuron is multiplied by a weight, and it's that weighted output that the next neuron receives. So neural networks are organized in layers. We have an input layer. We have an output layer, which is where the answer comes out. And then in between the input and the output, we have hidden layers. And maybe there's only one. You could even have no hidden layers, or you might only have one. In the early days of neural nets, we only had one hidden layer. But now with deep neural networks, you can have many hidden layers. And the more hidden layers you have, the more powerful the neural network is. So Teachable Machine is one of these deep neural networks. And the way you train a neural network is you show it some input and the network produces some output. And initially, all these weights are just small random numbers. So the initial output it's going to produce is going to be garbage. But you have a desired output, so you know what output you want it to produce. And you take the difference between what it's producing and what you wanted, and that difference constitutes an error signal. And then there's a mathematical formula that you use to send this error signal backwards and adjust the weights. And you can do this for all the different layers of weights. You can back propagate that error all the way backward, and you make a little adjustment, just a tiny adjustment to all the weights. And then you do it again. You show it another input pattern. You know what the output should be, and you just make these weight adjustments over and over and over again. And if you do enough of that, then the neural network will learn to produce the correct outputs. And hopefully, even for inputs it hasn't seen before, if it's learned the function correctly, it'll what's called generalize. It'll generalize to new inputs and be able to produce the correct output even for new inputs. So here's another neural network demo that you can play with. This is a face recognition demo. So you put a face on the input, and this is a deep neural network, so there's many layers. And at the end, it recognizes the face. It puts a box around the face. So I'm going to try and run that for you really quickly. Just waiting for Chrome to catch up with me here. It just takes a second to get up to speed. Here we go. Okay, so it sees me, and it should track my face, and it's doing that. And over here, this is the output of the first layer of the neural network, and the first layer is doing a kind of edge detection. So if I show it something like a checkerboard, then you can see it's responding to edges in the checkerboard image. So later layers are responding to other things like this. These units down here are actually detecting eyes in the image. So there's a whole tutorial over here. There's a list of experiments. So you can play around with this whenever you like. This is a freely available demo. And I just want to wrap up here and mention we have a resource directory at aifork12.org with lots of online demos, just like the two that I showed you, educational videos, curriculum resources, books, and more. So if you want to learn more about AI, there are lots of good resources available now. Everything we link to is available for free, and it can be really fun to explore that. So visit our aifork12.org website. We have a mailing list. You can find the link to join the mailing list on the website, or this is the direct link here. And everybody's welcome to join. Teachers, students, anybody can join. And that's my presentation. I'm happy to take questions.
Well, thank you very much, David. This has been very interesting indeed. Okay, now let's see what kind of question we have around around the globe, because from Nepal to Colombia, Nicaragua, and Puerto Rico. Any question, guys?
Can you hear me, Juan?
Yes, sir.
Yeah, can you hear me? I've been wondering since, AI could be good or could be bad. And he presented some facts, like losing jobs. But what about when people learn something which is not right, for example, or which is not complete, or which does not give the whole spectrum of ideas, or, I mean, are the concepts developed by AI correct?
Well, that's that's a problem that some of these AI systems like ChatGPT, they will make things up. The correct term for that is confabulation, although it's often called hallucination in the popular press. And so there's an opportunity here to teach people critical thinking, right? To teach them, don't always believe what the AI tells you. Go back and verify the facts, because that is a problem, even if it's not deliberate, right? So the AI is maybe trying to be helpful, but the way that these ChatGPT type systems work, truthfulness is not their highest priority. So, and there are people working on trying to correct those problems, but they're not fixed yet.
Well, besides that, what are the effects on people, young people believing things which are not real? Like, I'm gonna be rich whenever I get 30 years old, or things like having in a future some kind of hurdle, and they believe they can pass that easily.
I'm not sure that's really an AI issue, right? Young people, they need guidance from older, more experienced people to help find their best path in life. And that's going to be true whether AI is present or not. Like there are a lot of young kids who think they're going to be basketball stars, right? They like to play basketball. They think they're going to be basketball stars, or they think they're going to be rock stars, right? But it's really hard to reach that level.
Thank you. I was really going in that direction. Thank you. And what about when people are, like when many universities or small colleges will bring make believe people that they are really good in doing things, but they are not. Do you understand what I mean?
So, no, I don't.
Being a technician, a veterinary technician versus being a technician, like being a surgery assistant versus being a surgery. Do you follow me?
Being a surgery assistant versus being an actual surgeon?
Yeah.
Yes, there are some ideas in university which puts in the people, making them believe that they are fully professionals, but they have not they do not have all the titles and the licenses and stuff like that.
Yeah, I don't know what to say about that. I mean, there are licensing systems for things like medicine and law, right? You can be a paralegal, but you can't represent people in court. You have to be a lawyer to do that.
That's what I meant.
So,
could AI help in that area, or that could be too difficult?
well, I think what AI could do is amplify what the internet does. So years ago, before the World Wide Web, it was much harder to access knowledge, right? And so the specialists, the doctors, the lawyers, they had access to knowledge that the layperson didn't have, and so you had to believe what they told you. And when the internet came along, now people have direct access to highly technical knowledge. Now, they may not understand it as well as someone who's been to medical school or law school, and they still need to rely on professionals, but they're not completely at the mercy of those professionals. They can look up information on their own about a disease, about a medication, about the law. And I think that's improved society. It's made the average person better able to look after their own interests, to make informed decisions. So what I think these AI systems are going to do is they're going to amplify that, because it's one thing to give me access to the pharmaceutical data on some drug, but I still have to read it and try to understand it. It's another thing when I can go to these AI systems and ask them to explain stuff to me, and ask them direct questions and have them answer. Now, it's possible their explanation will be incorrect, and I'll need to go and verify it. But still, it's tremendously powerful that I can go ask this thing that's read more books. ChatGPT has read more books than any one human being can read in a lifetime. And so it's just a tremendously powerful way to learn new things. So I think the outcomes are going to be more positive than negative.
Thank you.
Well, excellent, David. Yes, I would like to ask you a question in general term. What is your recommendation, you see, for all these kids, how to start learning the artificial intelligence? Just for maybe, you see, if they take the ideas or what they want to be in life, you see, how can this, which will be the way to do it, the easy way to do it?
So I think there are lots of paths that they could take.
Yep.
If they go to our resource directory,
Yep.
there are online courses, some of which are designed to be taken by high school students.
Yep.
They could do some online courses. They could watch some videos, and there's some very good videos out now that teach the basics of AI. They could play with these demos. There are now AI extensions to Scratch, and so if they know Scratch programming, they can play with some of these AI extensions in the context of Scratch and learn some that way. And if they know Python, Python is what the majority of AI professionals use for Python programming, for AI programming. So they could actually, if they're pretty good programmers, they can start learning some of the AI packages that are available in Python, things like scikit-learn for machine learning, or PyTorch for neural networks in Python. So everything is open to them. It's really a wonderful time to be a student, because you can get access to all this stuff, and most of it is free.
Yes. Thank you very much, David. You see, that's exactly what I was trying to look and trying to get, you see, for the student. Because they say sometimes this is too difficult for me to understand. I think there is a process here, you see. There is a tremendous knowledge out there. And you have to be just patient in terms of what you are getting at what level. So, for the audience, you see, we need an evaluation, and you had a copy, you see, a copy of the form. Mm-hmm. So if you don't have a copy, just send me an email, and I will be glad to send you that. Okay, it can be after we finish. All right, and also if you had any question for additional question for Dr. Touretzky, you can send me an email also, and I will forward to him. Yeah, because this is a moment, and it's the time where a community, you see, will be engaged, and if we have the support of Dr. Dave Touretzky, you see, we can really do a great job. Okay, so thank you very much, Dave, and I would like if you can send me, you see, the copy of the recording version for this. Do we have any other question from the audience?
I see two hands are raised, so maybe we have a question.
Yeah, somebody, Susie is Karin, Sally Vasquez. Sally, can you ask your question? Oh,
I see Corey has a hand raised.
Corey, yes.
Okay, hello, I'm Corey and I'm from Haiti. So I'd like to ask, how can AI help someone do better if like it can't feel emotion? And do you think that in the future we'll be able to develop its like ethics and morals better?
Let's start with the first
Good.
part. Can you say that again? How can AI help people do better?
Yes, if it's like lacking a bit when it comes to emotions.
Oh, well, do better at what? So what is it that it should help them do better at?
I think she meant to ask how can AI help if it doesn't have any emotions or something like that.
I don't think it needs emotions to help people. If it's told that it's supposed to provide information, it'll provide information. It doesn't need to have emotions in order to fulfill those functions.
So, and next question, like from my side also, like, can we integrate emotions to AI, like in the future?
Well, people have done work on getting AI systems to act as if they had emotions, to pretend that they have emotions. So they can act excited or they can act sympathetic. And, you know, that might be, you might want that in, say, a companion robot. But then you could argue, does it really have emotions or is it just pretending to have emotions? And do we want it to really have emotions? Well, I'm not sure we want that because, you know, what if it got angry, right? Or what if it got depressed and didn't want to work anymore, right? So I'm not sure we want it to really have emotions, but we certainly want it to understand our emotions.
Yeah, like we can sometime ask Siri to just be excited and it does for us. So I think there's a little progress.
There's someone else who has a hand up. Letitia has a hand up, and Shmerinka.
Good morning.
Yes.
I'm
Yes.
Shmerinka. I'm from Haiti. So
Yes.
I wanted to congratulate you for this presentation. And my question for you is, how long do you think it can take to train an AI about some specific disease symptoms? And do you think it is really a necessity? And can we trust their proposed treatment? And can we trust them for making surgeries and such?
So how long it takes to train depends a lot on the complexity of the training data. So some kinds of machine learning experiments you can do on your laptop, especially modern laptops are really quite powerful. On the other hand, if you have a really, really large data set, you may need to use a data center. So it has something like Google Cloud or Microsoft Azure. So it really varies. As far as trusting AI to make critical things like medical decisions, I don't think that we should rely on it entirely. Where the AI could be really useful is in catching things that a doctor might miss. So if the AI says, "Oh, there's disease here," we should always have a human doctor check the results. But if we only have the human doctor, first of all, we may not have enough human doctors, especially in some parts of the world where the number of doctors is much lower than the need. And so if an AI can come in and help reduce the workload, so maybe it could scan through many, many people's medical tests and find the ones that it thinks are most likely to indicate disease, and make sure the doctor looks at those, right? And the ones that are clearly healthy, maybe the doctor doesn't need to look at those, and unless there's time available. But the people who are sort of iffy, right? It's not really clear, right? We want the human doctor to check what the AI is saying. So yeah, I think it'll be a long time before we let the AI work with no human checks. The same thing with surgery. Things like letting an AI drive a car. That's pretty safe. It's getting safer. And if it bangs up a fender or something, it's not, the downside isn't that bad. But in surgery, the risks of a mistake are much higher. So it'll be a long time before we give AI that much trust.
Okay, thank you.
Perfect. Any other question,
Yes, me, Leticia.
Leticia?
Okay,
Yeah.
so hi, I'm Leticia. I'm from Haiti also, and that was a beautiful presentation. That's not the first thing I want to say. My question is like a big question that involves, I say, many answers. The main point is asking, do you think in a near or like a possible future, the AI will be more involved in engineering as like let's say civil engineering, or maybe do you think there will be a time where AI will be able to, I don't know, reproduce itself? Like, do you think AI could be used in the production of like robots, for example, in a certain future?
Yeah, so let's start with the engineering one. I think AI is already in use in engineering. So people are using AI systems to help with designs, and in some cases coming up with designs that no human being would have come up with. Again, people are not letting the AI run unchecked, but the AI as an assistant to a human engineer can help solve problems more quickly or find solutions that are not so obvious that a human being might not come up with. So here's one example of that. People who are doing design of things like aircraft parts. So you have this requirements for certain stress and vibration loads that the part has to withstand. But also, it has to be lightweight. And so people can try and design these shapes by hand, but now there are AI tools that will help with that, and they'll design these crazy looking shapes that no human being would draw something that weird looking. But it turns out that they work really, really well. They have just the right properties to meet these torsional constraints and vibrational constraints. And so people are using these AI design parts because the simulation shows that they do have the desired properties that are needed. Now, your other question about AI self-replication. So there's a whole bunch of nightmare scenarios where things go really bad. So an example would be an AI system that develops super intelligence, so it's smarter than people, and maybe it doesn't have the same goals that we have. If it has its own goals, then it might decide, for example, that it wants more computing power. So if this thing is super intelligent, that means that it could be a super hacker, and it could just decide to say, take over the Microsoft data center using its hacking skills, and it could take over new data centers, and it could take over, if people tried to fight back against that, it could threaten them. It could say, oh, well, I've taken over this nuclear power plant here, and if you don't do what I want, I'm going to blow up this power plant, or I'm going to make your airplanes crash. And so there's a whole genre of people forecasting ways things could go really, really bad. And that's why AI safety is an important research topic now, and people are trying to figure out how to avoid that from happening.
Great. Absolutely.
Elizabeth has her hand.
Yeah, thank you.
Sure.
I really liked our meeting. I don't really have a question. It's just a statement. I'm really surprised about everything that AI is being doing. I'm certainly sure that there are some limitations yet, for example, in my career. as microbiology, but with today's meeting, I have seen some applications that we could maybe use through AI. For example, about the deep learning, there are some colonies in microbiology that grows with the same aspects or phenotypes, and they can be used to identify some diseases. So I guess it will maybe possible to find some applications, including AI and microbiology in the future, but not very far in the future, because there are some things that are consistent in my field. So it was nice. I really enjoyed it, and thank you very much.
Thanks. Yeah, I think there are lots of potential applications in microbiology. So disease prevention, for example, finding medications that could be more effective at curing or preventing microbial diseases. But also you could think about microbe design, right? So, microbes make useful things. They have lots of beneficial effects. And so what if you could alter their DNA and make them more useful? So what if you had microbes that would eat up pollution, for example? And
yes.
Doing that kind of
Sorry.
AI can help with that.
We actually do that, but I didn't really see the application of AI directly in it, because we usually study it as a biotechnology application where you can mutate some genes and also insert some other genes. And it's more the aspect we see, the focus we have, it's more bioengineering. It's more like that, but I'm going to think about it. Thank you for the idea.
Sure. So DeepMind recently released their protein structure prediction program. So this is an AI program that you can give it the DNA sequence or the amino acid sequence for a protein, and it'll predict the shape of the protein. And of course, that kind of thing is really important if you're doing genetic engineering for microbes, right? Those genes are encoding proteins, and you'd like to be able to predict what these proteins are going to look like and how they're going to interact. So people are already using AI in the biological sciences.
Thank you.
All right. All right, we are over an hour with the presentation. So this has been really good.
Liz has her hand up. Maybe she can be the last question.
Okay, the last question. Elizabeth?
Lisbeth. Yes, I'm Lisbeth.
Oh, Elizabeth Vidal.
Yes, I'm from the Dominican Republic, and I do have
Perfect.
a question and a suggestion. Firstly, doctor, I'd recommend another browser because Google Chrome is known for taking up a significant amount of RAM space and, for instance, not working well for multitasking. I saw you were having some trouble with loading the page, and there's that. Google Chrome is a bit slower in regards of stuff like screen sharing and multiple other stuff. And my question is, how would you integrate AI in a kinder classroom, for example?
In a kindergarten classroom?
Wow.
Yes.
Kindergarten, yes.
Yeah, that's interesting. So, when I first started on this AI for K12.org work, we were giving talks at conferences, and people were very skeptical. They said, why do you need to introduce kindergartners to AI? And I said, we're not introducing them to AI. By the time they get to kindergarten, they've spent 2 years talking to Alexa. So we're already even little kids interacting with these intelligent agents. And I think that's one way that you could bring this into kindergarten. Also, I think we're going to see a lot more AI-powered robots, and some of those could do well in kindergarten. So that's where I would start.
Great.
Thank you.
My pleasure.
All right, all right, David. This has been very interesting, and we will disseminate your talk. You see, since you are going to send me the the recording version.
I will.
So other people will listen to this. All right. Thank you very much to the audience. And remember that we need a feedback, okay, a written feedback. All right. Take care. Thank you much again, Dave, for this.